Hello. Today's warm-up is to write down on the table of contents PT September 18th, 2014, review for quiz on Friday. You're going to have a quiz on geologic features and the evidence for continental drift. So on a blank sheet of paper, you are going to write a title, review for quiz. And you're going to fold your paper Cornell note style and answer the following warm-up question. Alfred Wegener proposed the theory of continental drift. What evidence did he use to support his theory? Why was his theory not accepted during his lifetime? Take 1 minute to answer this question quietly. Okay, the time is up. So, can anyone answer this question? We know that Alfred Wegener used rock clues, fossil clues, mountain ranges, the puzzle-like fit of the continents, and climate clues to help support his theory of continental drift. And why was his theory not accepted during his lifetime? That's right. It was because he could not explain how, when, or why the continents moved. So today's agenda was to do our warm-up. We're going to review geologic features. We're going to review Wegener's theory of continental drift and the evidence. And for our exit ticket, we're going to think about our thinking and figure out which of these two above review topics we will need to review the most and why. So we're going to begin the review of geologic features. There are three types of plate boundary interactions. They are divergent, when the plates are separating, convergent, when the plates are colliding or crashing, and transform is when the plates slide one past each other without vertical movement. When we have these types of plate boundaries, there are different geologic features that are formed. For convergent boundaries, we have non-volcanic mountains, volcanic mountains, and islands. For divergent boundaries, we have rift valleys and mid-ocean ridges. And for a transform boundary, we have faults. We're going to review all of these, and you're going to tell me, by looking at a cross-section of the Earth, what type of geologic feature is going to be formed at a specific boundary, and the most famous location on Earth that we know that demonstrates that type of boundary. So let's begin. The first question I have for this diagram is what types of crust is involved? We can see continental crust and continental crust. And we can also see that the arrows are going towards each other. So we know that this is a continental-continental convergent boundary. The question is, what geologic feature is formed at this plate boundary? What is the most famous example of this continental convergence plate boundary? And where is it? Where is it in the world? The answer to these questions are: the geologic feature formed at this plate boundary is non-volcanic mountains. What is the most famous example of this? The Himalayas. And where is it? It's in the boundary between India and Asia. That's where the Himalaya mountains are formed and where they continue to rise to this day. This is a map that shows us where the Indian plate is moving towards the Eurasian plate. As a result of the convergence, the mountains, the non-volcanic mountains of the Himalayas are formed. This is another cross-section diagram of a different type of boundary. And the question I always ask myself is, what type of crust is involved? And I can see over here, it says oceanic crust. And I can see over here, it says continental crust. And when we have a convergence between continental and oceanic crust, the oceanic crust will always subduct. That means it will go under the continental crust because oceanic crust is denser than continental crust. When it subducts, a great amount of heat is involved and water heats up and gases heat up, and that creates less dense magma that rises up to the surface in the form of volcanic mountains. So the geologic feature formed at this plate boundary is a volcanic mountain. And what is the most famous example of this? The Andes Mountains. Where are they located? They are located between the Nazca plate boundary and the South American plate boundary, and they are in South America. Let's watch a short video clip. The next type of boundary is, we can see here, oceanic, and over here is also thin and oceanic. They're moving towards each other, and we can see something's forming in the middle of the ocean. And it is a volcanic mountain, but we know that the special case of a volcanic mountain that forms in the middle of the ocean is called an island. So, the geologic feature formed at this plate boundary is a volcanic island arc. What is the most famous example of this? The islands of Japan. And where is it? It's in the boundary between the Pacific plate and the Eurasian plate, and also the Philippine plate. Can anyone tell me what they think this is? What type of boundary this is? If you said divergent plate boundary, you're right. Iceland is a volcanic island formed at the mid-ocean ridge between the North American plate and the Eurasian plate. So the most famous example of this is the Mid-Atlantic Ridge. And as we just discussed, it is between the North American plate and the Eurasian plate, right smack dab in the middle of the Atlantic Ocean. Another example of a divergent boundary is this one. What is the geologic feature indicated on this map? If you answered Rift Valley, you are correct. This is the Great Rift Valley of Africa. The plates are moving in different directions and they're making this area separate. And we know from a video we saw that the prediction is that 100 million years from now, this is all going to be filled with water, ocean water. So this diagram is a review of all plate motions. Over here we have oceanic and continental crust forming volcanic mountains. Here we have oceanic crust and oceanic crust separating, making a mid-ocean ridge. Here we have oceanic crust and oceanic crust converging and creating a volcanic island arc. And those are some of the geologic features formed as a result of plate boundaries. What I'd like to do right now is I'm going to point somewhere and you're going to tell me what it is and what type of boundary is there, and the name, the type of boundary, and the geologic feature that is formed. So right here, the name would be Japan. The type of boundary is oceanic convergent, and the geologic feature that is formed is volcanic island arc. So let's have somebody try this one. Now let's have somebody try this one. Remember, I need you to tell me the name, the geologic feature, and what is the name of this famous place. What type of boundary is the one that creates this famous place? Let's do this one, and let's do this one. Now we're going to match these diagrams to these different places on Earth. If you guess that this one goes down here, and this one goes down here, up here, and this one goes, this one, oops, this one goes up here, then you were correct. Let me move these back. Now, we have a whole bunch of words that we need to try to match in these different columns. So I want you to try to match them where they belong. It's a little hard to see all of the words, so as we move them, we might be able to see and answer everything. Now we're going to move on to review continental drift. One of the most important evidences that Wegener used to support the theory of continental drift were fossil clues, and fossil clues give us both physical evidence and also climatic evidence. So Wegener's evidence for continental drift had fossil clues, climate clues, rock clues, and the puzzle-like fit of the continents. Pangea was the name that Wegener gave to when the continents were together, and continental drift was the theory proposed by Wegener that the continents have moved horizontally to their current locations. One of the most important fossils that was used to support the theory of continental drift is the fossil of a reptile called Mesosaurus. It was a freshwater reptile, and its fossils were found in South America and Africa. Wegener used it as evidence because he said a freshwater reptile could not have swum across the Atlantic Ocean. And therefore, his theory that the continents were together and that the reptile walked across the land was evidence that the continents were once together. A second fossil evidence, was the fossil of a tropical plant called Glossopteris. This tropical fern was found in Africa, Australia, India, South America, and Antarctica. But we know that Africa, Australia, India, and South America could have some sort of warmer climate. However, Antarctica no longer does. And how could a tropical fern live in such a cold place like Antarctica? Wegener proposed that this fossil formed when Antarctica was in a different climate in a warmer part of the world, back when Pangaea was in a different, and the continents were in a different location. Another type of clue deals with climate clues, and tropical plants were found in the Arctic Ocean. Wegener proposed that this island in the Arctic Ocean had moved from the tropics to the North Pole. And you can see here that there are some fossils of some plants. The other very convincing evidence has to do with grooved bedrock that is found in South America, India, and Australia, where glaciers no longer exist. You will see that a glacier will scrape a valley, leaving long stretches of rock that have been scraped by the ice. And why would that be there if there wasn't ice there at some point? And how could there be ice in a place that's so warm? Wegener proposed that these areas were in the past in farther to the North Pole or the South Pole. The last type of clue that Wegener used was rock clues. He said there are similar rock structures and layers found in South America and Africa. The mountain ranges of the Appalachian Mountains are similar to the ones in Greenland and Western Europe. And he proposed that these rock structures and mountain ranges were the same because they formed at the same time when the continents were together. With all that evidence, Wegener's theory of continental drift was not accepted during his lifetime because he could not explain how, when, or why the continents moved. So that concludes our review. So the question is, which two review topics will you need to review the most? Geologic features and the places in the world and the types of boundaries, or continental drift and the evidence that supports it? What do you need to do well on tomorrow's quiz? What is the expectation for the class average result of this quiz? And what is the expectation that you have for yourself? Take a few minutes and quietly answer these questions. Make a note on your planner that you need to study for tomorrow's quiz. And if you need help, come today during lunch so that you can get help if you don't understand something. When you are done with this question, if you need to, take out any materials that you need to use to study for the quiz tomorrow, and you may leave your binder. Tomorrow when class begins, you could put your papers back in your binders so it can be together with the rest of the plate tectonics units. Thank you very much.